Alright. So if there's a number in front of your function, and I'm going to give y'all some examples, and please write these down so you know what I'm talking about. If you have a number in front of your function like this, it's in front, it's not grouped with x. Here's another example. If it's like 1/2 x squared, it's not grouped with x, it's on the outside of it. Grouping means it would be inside parentheses or absolute value bars, right? So if there's a number in front of your x, it is a vertical shrink or stretch. Easy way to remember this. If it's not with your x, if it's not grouped with your x, it's closer to your y. And y is talking about up and down, right? So that's easy to remember, vertical. So what do you think is going to happen if it's grouped with your x? It's not going to change it vertically, it's going to change it horizontally. Good. Okay. Now, if it is greater than 1, so if it's a number like 2 or 3 or 4, it's going to be called a vertical stretch. So think big number, it's going to stretch it out. Now think about, what does it mean to be vertically stretched? What is that going to do to our graph? It's going to make it
bigger.
Looking for a certain word.
Expand.
No. If I were to take Kelsey and I were to stretch her vertically, she would become what? Taller. Good. And if I were to shrink her vertically, she would become shorter. Good. So stretch is talking about making your graph taller. If it's between 0 and 1, so what type of numbers are between 0 and 1? Fractions. Good. If it's a fraction out front, it's going to be shrinking it, vertically shrinking. So the first thing we're going to do is, just like yesterday, we're going to graph the parent function first. So let's do a together. X cubed. Where's the center always going to be for the parent function?
0.
Good. And now 1 cubed is what?
Go up.
1 cubed is 1. What is 2 cubed? 8, way up here.
Why is it?
Because 2 times 2 times 2 is 8. Alright, what's negative 1 cubed? And negative 2 cubed? Good. Go ahead and draw your parent function. So this is what x cubed looks like. Now the only difference between this parent function and this function is that it's multiplying everything by 1/2, right? So easy way to do this, we could multiply all our what values by 1/2. Does anybody know? What you doing? Alright, then let's make a table then. Go ahead and make a table for this one. Put in negative 2, negative 1, 0, 1, 2. Using the same x values. If I plug in negative 2 here for my y value, to find my y value, what's negative 2 cubed? Divided by 2? Negative 4. Good. I'll go over that one more time. If you plug negative 2 in right here, you get negative 2 cubed, which is negative 8. Divide that by 2, you'll get negative 4. So look at negative 2. Wasn't the y value negative 8? All we did was divide it by what? 2. Good. So the y value at negative 1 was negative 1. What's negative 1 divided by 2?
What about the x?
X's don't change.
Not my dad. 1/2 negative.
Thank you, Derek. What are you asking?
Well, also my dad, the 1/2 x.
This? This?
Yeah.
That's the function we're graphing right now.
I know that's my life. It doesn't, it's just a little bit good.
It's the, what now?
Like negative 2 squared, the cube is negative 4.
No, negative 2 cubed is negative 8.
Yeah,
We're going to divide it by 2 and get negative 4.
Divide by 2 is negative 4.
Yeah.
I'm saying like the x doesn't do anything.
This is what you're plugging in for x. Okay? This is what you're plugging in for x. So it does change depending on what the x value is. Alright. Going back to this one. Negative 1 cubed is what? Divided by 2 would be negative 1/2. The next one would just be what? The next one? And the next one. Go ahead and graph those dots, and that's going to be your transformed graph. Make sure you do it in a different color so you can see the difference. So on ones that are cubed or like cube roots, you're not going to be able to tell the difference between it that much. But you'll see when we get to absolute value and ones where it has an actual slope, it changes it a lot, the graph of it. So for example, this next one, absolute value of x, the center is going to be where? And the slope is what? No, the slope of our parent graph. It's just 1. So we go up 1 over 1, up 1 over 1, up 1 over 1. It has to be symmetrical. So this is what your parent graph will look like.
Why does that have to be symmetrical?
Because it's an absolute value function. And the 3 is just going to change the what?
The sign.
No. Will this 3x right here change the center of your graph? Is it moving it left or right or up or down? Alright, I need y'all to talk to me.
Up and down.
No. Is anything being added or subtracted right here? No, so it's not moving left or right, not moving up or down. So will my center change?
No.
This just changes your what?
Slope.
Slope. So from here you would go up 3 over 1. Good. Go ahead. Go up 3, 1, 2, 3 over 1, up 3 over 1. And you can tell that this graph is taller than our parent graph, and that's because we're stretching it. I want you to do C and D with your group. We'll worry about these questions in just a minute. Do C and D with your group. So graph the parent function, then the transformed graph. Do I need to scroll back down? Center's always at 0, right?
Correct.
And now just plug this. 1 squared is going to be what? 2 squared? That's it.
What number are we doing?
C and D. That way you got yourself.
Code.
Yeah.
You said cool.
So how would you change it to?
I don't know.
Would you just go up 2 over 1 from 0? So would you just go up 2 over 1 from 0?
You can't use the slope on this one because it's not x. It's x squared. So all you have to do is multiply all your y values by what?
2.
So 2 times 0 is going to be what? Still 0, so you swap it out right there.
Okay, I'm gonna make one check.
And then this one, 1 times 0, I mean 1 times 2 is what? Good. So that dot will move up to 2.
Up to 2 or 2?
No, 2.
Right here?
So then multiply this y value by 2, you're going to get what?
0, 1, and 4.
8.
Good. So 8.
It's just hard. Over here?
So you can use the slope because it's not just x, right? So just like this one, how we just take all the y values divided by
That's not right.
now we take all the y
It's
values
not?
and what?
How is it not?
So 0 times 2 is going to be 0. This
You take those two.
y value of 1 times 2
I mean, I messed up like 5 times.
so this is going to be 2 now.
So it goes that way.
So over here.
That's
So
right.
this one you go to what?
How you get that?
Because it was 4 and 8.
It's 2 squared, which gives you, I mean 4 squared gives you 8.
4 squared gives you 6. 4 times 2 gives you
4 squared gives 2 squared gives you. What gives you 8? 4. Wait, what?
2 times 4 is 8. Yeah, because she said you use your Y values. And 2 squared is 4. 4 times 2.
I have 8. Is it gonna be 4 8 or is it 2
I don't know.
8? 4 times 2. I'm confused. Mid-horn. I knew it.
So is it 2 8 or 4? For this one? Yeah.
Or this one?
Because I've always been taught to use a table.
You can use the table.
So would you just do 2 times?
Except you gotta use the same x values you used here, which was -2, -1, 0, 1, 0.
Okay, so what would you put?
Now find the y values.
Okay, and you just do those times 2, right?
After you square this, then times which part?
Times 2 is 8.
I don't even back up. They come up.
Yeah, that's right.
That's like 4 8.
That was me.
All you're doing is, notice how on this one always
What's
is
4?
It's okay.
the same thing in the multiplier.
I just,
So
I
what's the
told
y value
you.
here? Times 2.
He's like, 0. Right.
I didn't say that.
What's the y value here? Times 2.
I'm just going to stop with these colored pencils.
This one that was 1, you multiply by 3, right? What's this y value? Because 1 was our y value, times 2 would make 2. And this one.
Oh.
This one, your y value as well.
Wait, you said 2 times 1.
Yeah.
You look good.
I'm just talking about when
I
I
want to y'all
want
game.
your y value.
Miss Horton?
Yes.
Hey, did Karen Edwards, was she in second period today?
No, ma'am.
Okay, thank you.
You'd be like this.
This y value is
She
12.
was like, she the yellow song.
So times 2 would be.
Was it going over there? Uh-oh. And smile.
That's the function.
Why you doing
Let's go over this. Alright. So let me borrow your paper. You're not done. Who's done with both of these?
Oh, we supposed to.
Yeah, we didn't do
Okay. On this one, this person made a table for their next graph. Notice you have to leave the same x values. And how did they get the y values? How did you get 8? Plugged it into which one? Good. So if you notice, if you look at our original graph, our parent graph, at first for this, the y value was 1, and all you had to do was multiply it by this 2. Just like up here, let me go up some. All the y values, we just took and divided them by 2. So all the y values here, you just take them and multiply them by 2. Does everybody see that? If you're more comfortable with making a table, that's completely fine. Why couldn't we use the slope to move on this one? Why couldn't we use the slope to move on this one? Good, it has an exponent. Good, it has to be just x in order for us to use the slope, which moves me to this one. This one we could use the slope. All you have to do is start at 0 and go what? Up 1 over 3, up 1 over 3. So let's go back to these questions. What do you notice about the x values of your original and your transform? Alright, Alright, I'll just start calling on people. What do you notice about the x values of your original and your transform graph, Amber?
On C.
On any of these. Your x values compared to this graph and this graph. So here's your x values. Did they change here?
No. Oh wait. On D or B?
On any of them.
Yeah.
Alright, so let's go back to this one. On our original, we used the x values -2, -1, 0, 1, 2, right? All these x values. For our transform graph, did we use the same ones?
Yeah.
Yes. Does everybody see that? Y'all know what I'm talking about? Our x values for this one, we used -2, -1, 0, 1, 2. And for our transform graph, we used the same x values, right? Okay. So the x values of the graph, we can say they did what? Stayed the same or did not change? The y values, did they change? Yes. Good.
How you do?
How did I do what now?
How you get
This one? I'll be with you in just a second. So anytime we're doing vertical shrink or stretch, you can leave the x values the same. It's the y values that's going to change. Does that make sense? Okay. You'll pass that to Michaela for me. Now flip it over. Now we'll talk about horizontal shrinks and stretches. And this is when a number is on the inside with x. And when I say inside, I mean group with x. Grouped with x is a horizontal shrink or stretch. So here's where it's with x when it's on the inside. Here's where it's with x on the inside. So it has to be grouped with it. Now, we talked about yesterday x is a joker, kind of like your ex-boyfriend or girlfriend, right? So anytime you're with them, you're going to be doing the wrong thing, the opposite. So if c is greater than 1, like 2 or 3, you would think it's going to be doing what? Stretching or shrinking? Stretching, because it's a big number, bigger than a fraction, right? But x is a joker, it's going to be the opposite, which is what? Yes, shrinking. So anytime the number's inside with x, like square root of 2x or maybe 3x, it's going to be shrinking it horizontally. Now what does that mean in terms of your graph? It would be doing what? Making it skinnier. And then a horizontal stretch would be making it fatter or larger. And so if it's a fraction on the inside with x like this, or perhaps like this, it'd be a horizontal stretch. Alright, so you're going to be doing the same thing we did on the other graph, on the other side. Let's do this one first. Let's go ahead and draw the parent graph of square root of x. Is the center going to be at 0? Yes, always for the parent graph. Can we take the square root of negative numbers?
No.
No, they're not real. So what's the square root of 1? And we don't know the square root of 2 and 3. That's going to be a decimal, right? But we know the square root of what? 4, and that's going to be, this is what your parent graph's going to look like. And now for the transform graph, square root of 1/2 x, let's make a table.
Why should you graph like that?
Why is it like what? Like this? Because you can take the square root of any number that's positive, so it's going to go on forever. Just can't take the square root of negative numbers.
You get 14.
Miss Horton?
Yes.
Hey, Caleb Formal, was he in second period today?
No.
Okay, thank you.
Okay. So the x values, what could I start with? 0 and go up, right? Let's do 1 and 4. Alright, so if I plug 0 in here, what would my y value be? 0, right? If I plugged in 1, that'd be like square root of 1/2. Somebody type that in on their calculator and tell me what that's going to give us. Square root of 1/2. 0.7. Okay. And now if I type in 4, to this function, it's going to be 1/2 times 4. And what's 1/2 times 4?
2.
And what's the square root of 2? 1 point.
5.
Don't guess.
1.4.
Alright, graph those 3 dots. So at 0, 0, at 1.7, and 2, 1.41. And like I said, the graph won't look much different when it's functions like this. But when we actually can use our slope, that's when it's going to look different. Alright, I want you to try A and C with your group. A and C. If you'd like to check these on your graphing calculator, you just don't know how, let me know so I can show you. You know how to do it right here?
Alright, type in y equals. And now let's just do this one. So for absolute value, what you get math. Yeah, the rest of them are on the page. Go over to the number. There it is. See what it says absolute value? Now I'm typing in TX. And then all you have to do is press graph. That's your transform graph. And if you want to see it compared to the original, just type in both of them. And then absolute value of x. So you have absolute value of x. So it's just on the graph. There's your original. All you have to do is copy it.
I just copy.
That's it.
And get the grade.
Do you use that? Yes. Yes, I'll use a table for all of them. Okay.
What happens?
Nope.
What did you go with this?
Yes.
Wait, how did you do that?
And I'll show her.
Okay, look. Come on, kids. I bet you. Now, okay, wait. Y equals. Say that out. Type in absolute value 2x. Click math. Go over the number. Enter. No, go back to absolute
Oh,
number.
there it is.
2, and then click your x. The x.
What is it?
Enter. Click graph. You don't use this right here. That's a transformed one. Now, go back to y equals. Go down. And do absolute value of x. Merry Christmas. Good. You got the answer.
I've never seen that.
Did your mom not feed you? So I just started grabbing. You didn't eat breakfast?
I did.
Oh, good. You.
And just eating it. That's fine. So you can just
I like
use it like
food.
that.
You ever had
Is that what you do? Okay, good.
a blackberry?
From there.
You black person house, and that's what
You don't have to look at it.
You know,
Like how you said this is.
you live in
it's
now.
actually.
Yes. This is beside it, so same as your slope, right? So from here you can go. Yep. Alright, can I borrow somebody's paper? Or are y'all still working? Can I borrow yours? Alright.
For this one, it's easy because on the absolute value ones, you can use your what to move your points. Slope. So here's the first one. Which one's my parent function? Which color? Yellow. And this red one is my transformed. All you have to do is start at 0, 0, go up to over 1 because that's the slope. Okay. And when can we use our slope again? When x has an exponent of what? 1. Good. When x has an exponent of 1. When it's not like x squared or x cubed. This one, same thing. We just have to go up 1 over 3. So which one's my parent function? Red. And my transformed is an orange. Alright. Any questions about graphing those? Alright. Flip it over. And we pass that to Abigail. So this is your cheat sheet that you will get to use on your test, your next test. But let me explain it because it's kind of confusing right now. This is talking about vertical shifts when it's moving up or down. This one's talking about horizontal when it's moving left and right. Reflection is when there's a negative. The vertical stretching and shrinking is just what we did first on this page. And this is what we just got done with. So this, if you want to copy it or cut it out of your notes, not right now, but later on you can use this on your test. Just don't forget, okay? Alright, so I want you to work A through F with your group. When you get them all correct, you can pack up. A through F. Whatever you don't finish, let's not do it for homework because you already have that packet, okay? But work A through F together. Once you get them correct, you can pack up. All you need to do is graph the parent and the transformation. Let me know if you need help.
So when you go to the left one and
The stuff you're doing in the groups, you just need to finish that.
You zip code?
yeah, left one.
I thought you were going right.
Which
No,
one?
you go
That's your
left.
first. I typed that in.
Yep, that's fine.
And how would I know, like, was that the
This
negative
is
one?
negative 1 3. That's your center.
Wait, negative one.
And then your slope here, look in front of x, that number's what?
Mhm.
So you go up 1 over.
Okay.
Which one?
Very good. Not right, but x is joker. Yes. On the inside, you're moving left to right.
So when you go, when it's down,
This is when it's on the inside.
which month, you know, like, which month, like, when you go.
Like when it's positive, you go negative towards the
If
negative.
it's on the outside, you don't have to change it. Go to down 3. This one's when you
So
change
we're not, so we're not going to
Say
go.
thank you.
No, it's on your right.
The question is, when do we know if we're going up or down?
if it's away from x, if it's not grouped with x. Let me know if y'all need help. That's your bracket.
Duh. I got it. I got it.
Then it goes up to.
You just.
So you would flip it over, but you go up to, that's the center. Right?
Kelsey, you know what the calculator say?
Look at all
I ain't gonna tell you what she does.
Wait.
And now this one. This is in the left and right.
You got the same right?
Yes. Left and
So you flip it, so you 2,
Alright. I was thinking, yeah, my friend.
How do you do that? How do you do that?
She said, "How you do that?"
The second one.
Yeah.
I just knew that.
Transformation.
Because if it's positive, then it goes towards negative. Like it's the opposite. So you go over, you go left one, down three. You go to each stop and go left one, down three. Left one, down three.
And now we're
So say after your parent back. You got the same
it'll
answer.
stay the same, and now this one you
Did you not?
up 4,
Basically, you just use the equation. See how all your points go. Left one, down three. Left one, down three.
Why you get this one?
Left one, down three. You do it for every point. Okay, the square root one goes like this, right?
Square root starts at 0 and goes up.
Goes up.
Because can you take the square root of negative numbers?
No, you can't. Okay.
Miss Horton?
Yes.
Hey, did Jalen Graham make it in?
He did not.
Thank you.
I know you tried to call me.
I'm sorry, give him up. Being my class got put in that.
Okay, so for this one, how does it go?
Okay, tell me what the graph is now. It's 0, 0.
0, 0, 1, 1, 4, 2.
No, thank you.
You're welcome. So if it's 5,
Yes. Why don't you tell me to calculate? Shit, you can do it like this. I'll get the right grade. You know, points out.
would you move them Wait, what's the answer to Darren? What's the absolute values for this?
Don't know.
So dull. Ow!
But she's trying to go too
What
wait.
was your I need to zoom.
Did you just zoom on my thing? Stop. Can you not see me?
Why is it orange?
How you do all that stuff? Show me how you did that.
I don't know what to do. That's all I I'm going to make a table. Is there a So would you do? No, you wouldn't make a table. Did you get it right?
Yes, that's the answer.
How do you know what you want to do?
You just did it. How you did it? Good.
Okay, I'm going to do the paper.
Okay, it's 0. So it's gonna be a big 1. So it's gonna be 1. At the 1, so it's gonna be right there. It's gonna start right there. I don't know how you did this. But you did it. Put that out. 1. 2.5. So it's going to be 1. 2. 2.5.
2 times.
And then,
That's not right.
yeah, but 2, 3.
Because she's a pain. If it's not outside, then where's it just outside?
Look, I'm a younger.
How do you do that?
Uncle Peter.
I know, but I don't remember how. What number is it?
Anybody talking to about? That's what I did last time. Because I did 10 pounds more than me. This one. Is that right?
Finish up. Which one? I know, but I want to know how to do it without working. If you can't figure it out, like how to do things.
Alright, we'll start here tomorrow.
Make a table. Now which exercise do you have to start with? Okay. So plug in 0 and then you get square root of 0, which is 0 plus 1. Yes. See, I didn't think you could do that with. Yeah, that's fine.
Oh, yeah, you made that
I almost left without
I was at the police department just giving them shirts.
Giving them shirts.
Yeah, so we got her shirts off, but me and I followed other people. What did I miss?
A lot.
You missed a lot.
Who are you with?
Coach Freeman.
What is it? Send me an email.
On the other.
And your notes are in the third grade. They'll be over the next class in the spring.
It's hard.
It is not hard.
Miss Warren, don't know about it. Graphic is hard.
Wait, what's your email, Ms. Warren?
Avery.Horton
Was it a 2.4
acsboe.org. It was 2.4.
Right, okay. I have not the pre-question one. I have not done that one yet.
Okay.
I don't even see it right there. So, can I get that to you tomorrow?
Yes. And let me show you the piece-wise homework. You're welcome, and
What else?
the mid-test, that's all.
I'll put that on here.
Got it. Thank you. So those two things are the only things.
Alrighty.